Okay, so something you guys are going to have to do a lot of is fitting a given set of points that you've measured or taken and to a function, and usually that's a line. And what we call this is linear regression. So I'm just going to explain it quite simply, and then I'll show you how to use it on Excel. So let's just draw up some a little axes there. Alright, now let's say that we're measuring the current, which is in amperes, and that's at different concentrations. Right, so that's grams per litre. And what we expect is that as you add more concentrated solution, your measurement in amps is going to increase. So let's say our first measurement down here is kind of there, and then it kind of goes up there and roughly there and there. And let's just say this one here goes down a bit. Okay, so if we were to kind of draw a line through that, it would kind of look like that. And we know that the equation that describes a line is y equals mx plus c, quite simple. Where y in this case is the current and x in this case is the concentration. Now there's an associated error with each point, so you can see here that there's a deviation here. Let's just call this E1. This is the error 1. A little deviation here, let's call that E2. A little deviation here, which is E3, and a little deviation here, which is E4, and finally this one here, which is E5. And we say that basically we want the line which has the minimum amount of error, and that's kind of that's what we're going for here. So how are we going to give the computer something that it can try and minimize, I guess, in order to give us the best line? So let's rewrite this so that it's kind of more what we're used to. So y in this case is current, which is in amps, is equal to m, which is the slope of the line. M is just the slope. It's rise divided by the run. It's equal to m. X in this case is the concentration in grams per litre, and then you have plus c, and this is the y intercept. Alright, so now that we've got that, linear regression basically works out a way of thinking about these errors and then giving it to the computer so that the computer can optimize this value here and this value here to give us the minimum error. So the first thing that we don't want is we don't want negative numbers. Because if we had an error say down here, and this one here would probably cancel out with that one, but what we want to know is the total error. So that means that we can square the numbers, and that removes that problem. And the second thing we do is we average the errors. And we learnt that earlier. That's basically Pythagoras' theorem. So you want to this is how you kind of find the average of the errors, and so that is the sum of squares. Root mean squares, it's usually called. And so we write this as E1 squared plus E2 squared plus E3 squared plus E4 squared plus E5 squared. Oh, there we go. And we take the square root of that. Oh. And this gives us what's called our chi value. Now this is a Greek symbol, Greek, and that's the English equivalent, chi. And the computer, so this is number 3, the computer changes M and C to give us the smallest chi value, which is the smallest error, and that's kind of what you expect. So next I'll show you how to do it in Excel.